Uh, let Vijay Lakshmi invite Naresh, and we will get into the program. Thank you. வாழ்க வளமுடன்.
Yeah, shall we start with small meditation?
Yes, ma. As usual.
Thank you. வாழ்க வளமுடன். Tarunaya, can you conduct the meditation, please?
வாழ்க வையகம், வாழ்க வையகம், வாழ்க வளமுடன். With the grace of divine and Guru's blessing, let's have a beautiful meditation. Let the atmosphere around us be purified by divine energy. May the divine energy lead us, guide us, protect us in all the activities we do. Feel the divinity flowing into us, purifying ourselves. In this beautiful state, let's get the blessing of our mother, father, Guru Vedatri Maharishi. We meditate at Agna. Turiyam. We conclude our meditation, spread the energy throughout the body. We bless ourselves with the grace of divine. May we enjoy good health, long life and wealth, peace, prosperity, happiness, and wisdom. We bless everybody. Conclude our meditation and we'll start a beautiful session today. வாழ்க வளமுடன்.
வாழ்க வளமுடன். Thank you, Tarunaya. வாழ்க வளமுடன். In today's session, we are going to have a presentation from Naresh sir. And you all know he already presented the initial part. Today we are going to have the continuation of it. As we are all excited since this is the technology world we are entering into, stepping into AI. So as we all know, as we are with the Vedatri Maharishi's sky system, how man is superior than anything else. This is the only part that is going to show that our superiority. So as this is Dr. M.V.R. Aya's dream come true visual project. So as we are all excited and we are going to have Naresh Aya's presentation now. Thank you, Naresh Aya. Please present. வாழ்க வளமுடன்.
வாழ்க வளமுடன். Let me share my screen here. Let me know once you can see the screen, please.
We are able to see.
Yeah, one sec. Sorry. One sec. So, today I'm going to talk about the energy particle simulation and how I was trying to simulate this the concept of energy particle, basically from the divine dust particle. I'll show whatever work we have done, and then actually, so there is still more work to be continued here. So I'll show the results till today. Yeah, okay. So, and then this is the. Can you see everything, the whole thing, or one second? So
We can see the full screen.
A full screen, right? You can see the everything, right? Whole
Yeah.
PPT. Good. Okay.
No, from
So
space,
basically,
the word in text only we are seeing.
yeah, that's all. So right now,
Okay.
just go through some PPT, and then I'll show the demo, everything. Okay. So this is the definition of space given by our beloved Guru Maharishi, Vedatri Maharishi. So it says, what is a space, right? Absolute consciousness, everlasting, singular, almighty, all penetrative, thoroughly permeable, highly transparent, imperceptible, dark fluid matter. So here he says a matter, okay, and characterized by quivering kinematic self, compressive, inexhaustible, ever increasing surrounding pressure, which results in formation of the dust particle. So here, each and every word matters. So if you really analyze each and every word, we know what the the divinity of the space, and also the force involved in the space, everything. Like what is the characteristic of the space? Everything is given as one statement here. So if you you clearly say it's a dark fluid matter. So typically we think space as nothingness, right? So that's not the case here. He says it's fluid matter. So in addition to that, I just, instead of matter, I'm saying it's a super material and it's super elastic, basically. So it can stretch, and it can never break, basically. So it can never break. That's the whole thing. So whenever the dust particle is formed, it will never breaks. So the dust particle is just part of the space. So there's space is everywhere. That's the concept here. So it's not, when the dust particle forms, it's not going away. It's there, still there, right? So basically, if you look at how the dust particle is formed, basically at any point when there's concentration of the compressive force, what happens is the space, because it's kind of a super elastic material, it starts folding. It starts folding around that point, and then the compressive force makes it the kind of a globular form there, and it's basically, and we say it starts spinning about an axis. So only if you think about it, right, only the compressive force, it's not, you need more than compressive force for it to spin, right? So what is the other things that we need to think about is, if you look at it, that it's not only compressive force, but we need also a tangential force on the particle. So the tangential force is the one will make the particle spin. So this is where I was trying to think how the tangential force comes into picture. So still I don't have proper explanation. The compressive force, it also, like when it reflects or something, it also becomes a tangential force, so that the whole thing starts spinning there. So that's one thing, we need to figure out. We should have a proper explanation how the compressive force also becomes a tangential force, so that the whole particle starts spinning. This is the thing that we need a proper explanation for this. So basically, when it starts spinning, anything that starts spinning will have an axis there. So that it automatically forms an axis. So that whole the space, it starts spinning around that axis. And then we need to think it's just but even though it's spinning, the continuity is there. The space is there. It's nothing. It never broke out from the space. Only a tiny portion of the space starts spinning, and around that still there is a space. So there's no discontinuity there between the space and the dust particle. So if you look at this is how it is, right? So for example, sorry, did you see that animation? Yeah. So if you look at it, like, when there is a repulsive force, right? When there's repulsive force, basically then each particle moves. What it means is, basically, if you think about it, right, when there is a two particle and in between there is only space. So how does the force, right? How does the force felt by the other particle, right? So basically there's only space in between these two particles, but the force needs to be transmitted. Somehow needs to be, conveyed to that other particle. So only what is there? Only the space is there. So space, basically what happens when this guy starts spinning, one of the particles starts spinning at infinitable speed, that there is a frictional force on the space, right? And that force, basically what happens is it makes that the space itself, what thinks, okay, we need to balance that force, and then it tries to expand, right? So that expansion around that the is the one that is felt by the other particle as a repulsive force. So that's how it is. I felt like the force is conveyed to the other particle. When there is a just two particles or more particles, and then the one from one particle to other particle, how that the force is transmitted. And basically, it's a space, right? Space basically expands or contracts. That is felt as the what you call the repulsive or compressive or attractive force there. So again, when this is the thing that I think I talked about many times, that whenever the particles start spinning, and then they start into a kind of a layering, right? Alpha, beta, theta, and delta, right? So those are the states that the dust particle will align itself in a energy particle, right? Then the life force particle. So that's why I'm trying to show that. But this one, when you see the demo, you'll see. I'm not able to get this layering yet, because I think I'll talk about that during the demo. Why, and then what is the reason, and then what can we do to get this layering? Okay, so this is the concept of the four states: alpha, beta, and then the theta and delta, right? So in the energy particle. So these what you call these dust particles are the ones that give the what you call the characteristics of any energy particle. Each energy particle can be different. Each one has its own characteristic, but that characteristics comes from the underlying dust particles, the spin of the dust particle. Those things, and then the amount of dust particles in that energy particle gives the characteristics of each of the energy particle. So when you say any energy particle, everything like electron, proton, neutron, the subatomic particle that we know, they're all nothing but energy particle, which has a different which has a quantity of dust particles, and then the speed in the dust particles, they make this electron, proton, and neutron together. So when it starts, is when the energy particle, basically when it starts, also it also starts spinning around an axis because the inherent nature of the DTP is spinning, and then when it starts spinning, there is a frictional force between the this energy particle and the surrounding field as well, and then it also starts releasing this DTP divine dust particles into the field, and this released dust particle, basically the divine dust particle interacts with the surrounding field, creating a wave. If you see, it's like a ocean. The dust particles is like a ocean, and this released one goes into that ocean, and then it is getting compressed, because now it is totally released. It is released from the dust particle. Now it is trying to enter into that field, and it kind of perturbs the entire field around the energy particle. And that field, if you think about it, space contracts and then also expands, right? So that's where that whole wave kind of nature comes into the picture, which we called as a magnetic wave. So eventually these dust particles dissolves into that space once it is released, and it's kind of ripple effect that we feel, and that ripple effect is the one we call the magnetism. And the same, the ripple effect on each of the, depending on the field, we get a pressure, sound, light, light or heat, and taste and smell, depending on the field. So those are the 5 fields, and then we get the 5 transformation effect there. And these are because if you think about it, it's a 3D in nature, right? All this stuff. So it can be a longitudinal wave, it going like the as shown in this simulation here, it shows how the wave can go longitudinally. And the next one is I think this one already covered, but anyway, this one is the transverse wave. So the going up and down kind of a stuff. Okay. So this is the transverse wave that we see. And now, if you think about this is where the what you call the basis for my simulation starts. How I try to simulate this. So if you look at it, like what is the one of the main thing is the centripetal force. And the centripetal force is like, if you think about it, right, it tries to, whenever when an object moves, so there's some kind of a force trying to push it, right? If it's trying to go linearly, but there is a force from outside tries to push it, so when it tries keep pushing it, it takes a curvature path, and then the force is towards the center. That's what, so it's the centripetal force that is acting there, right? So that's what the centripetal force. So basically, if you look at this formulas, the force is equal to mass times velocity square by the radius of that the circle, right? That's from the center. So that's what it is. And here omega is nothing but the angular velocity, if you want to write it in terms of angular velocity. And this is where we say the linear velocity is equal to angular velocity by r. So what this means is when the angular velocity remains constant, when r is equal to 0, basically the velocity is 0 at the center, okay? And when r increases all the way to the periphery, the velocity, the linear velocity is high. That's what this formula says. Now, if you what is happening here? So this is the simulation of that centripetal force, like with just one single object, a particle there. So it constantly it moves. When they say it's a constant velocity, so it's going around at a constant speed there. Okay. And now, so this is in addition to that, what we have is today, like not only the single particle keeps moving around the center, but also we have this multiple particles, right? So there are so many billions of what you call the dust particles within energy particle, and whenever the particles come closer to each other, there should be some kind of interaction between those two particles, what you call the repulsive force between those two particles. So I was trying to simulate that, saying if you look at I took that the Newton's gravity, right? The force, the force is equal to G m1 m2 by r square, right? So I was trying to use that kind of a concept here, but I took that instead of taking the G, the gravity constant, I took that as a spin. Basically, there is a I spin, then basically what it means is there should be more repulsive force, right? So that's what I assume. I try to assume that, and in my simulation, so there is a spin factor associated with each of the particles, which in over time this one keeps reducing. When as it starts simulating, then it slowly I'm reducing that spin effect. So that there'll be lesser kind of force between these two particles. So I was trying to simulate that. And also there is an influence. One single particle, what is the influence radius, between there some particles can be at different positions, right? It can be very far, but that's the influence radius I took, so that only the particles that closer to this particle within that radius contributes to the repulsive force. So that's the assumption those are the assumptions that are made here for the simulation. Okay. And let me go to the simulation now. Actually, this is the one that's still this is the centripetal force I was talking about, and this is the actual simulation. I was trying to run this just before, and then here if you see, what I noticed was during the simulation, okay, and then if you sum near the black hole, you see always a chaos there. Okay, it's not that is this whole thing is becoming like sometimes this gain high velocity, and then they start spinning around this the center. So I was wondering how come this is happening. Okay, then I was trying to read through why there is around the center there's so much chaos there, and these guys go very fast around that center. And also like some of these the colors that you see, the green ones are the old ones, and then the yellow is the white ones are the the particles that I added now. But slowly, what you can see is somehow these guys can escape this guy. Like the outside, the energy particle will go out. But again, somehow these particles eventually go and then go to the center. Okay? It will go to the center point, the black, what you call the space. It falls into the space. Sometimes you can see the spiraling effect that the particle goes and spins and goes into the black hole. Like what do you call the space. So I was wondering why this in the simulation I'm seeing this. That's when I was trying to read through. Is this the nature, or is this how it is? Then that's when I found. So I was looking at, so I took an hurricane as an example. Okay, so in the hurricane also we have the similar effects, right? So in the hurricane, typically the center, the wind speed is very low, right? And then it's like sometimes they say it's like a very standstill kind of a stuff at the center of the hurricane. But after that, I saw this peculiar thing. Okay, around that hurricane, right? The red one. If you look at the red one, that's where the very high strong winds they exist, and then slowly when after that there is a transition, right, and that's where it goes into very light winds at the outer edge. So but in around
Naresh, your volume got muted.
what is it?
Yeah, now we can able to hear. Thank you.
So did you hear the hurricane stuff that I was talking about? Hello?
Yes, we are able to hear.
Yeah. So I was wondering then, I also thought about, okay, let's look at what happens at the, what do you call, the center of the galaxy, which is which has the black hole, right? I was, one second. It is not working. So if you look at here, right, this is in our Milky Way galaxy at the center, there's a black hole called Sagittarius. Okay, it's a huge, very huge black hole. And then if you see the stars around, it is like surprisingly the stars around the black hole, it moves really fast. Like I was more than the speed, like other stars, like around that, at the center it's like a big chaos there. Like it's not even there. Like the whole thing is like a chaos. Sometimes the stars go in anti-clockwise direction and also clockwise direction. It is like that's what some of the studies said, and that's what I was wondering whether that's the nature. If you in the simulation, when I was wondering why there is that the four like sorry, I think that the YouTube is going. Let me stop that. So I was wondering, that's why maybe, at the center when it moves, but because the particles are very close, it gains, somehow the particles gains the velocity there, it depends on, like, and then gains velocity and then slowly circles around that black hole and falls into that black hole, It all because if you see the interaction wise, it keeps going, but when there is a particle close by, what happens is there is a sling effect that comes into picture. So if you think about it, right, when you launch the satellites, etc., they try to use the gravitation of the planets to like sling the satellite, to boost the satellite speed there, right? That's one of the technique they use, using the gravitational force of the planet, to make boost the satellites into space, right? So that's one of the things. So if you look at the same thing happens when the particle come closer to each other, that is some kind of it tries to repulsive force try to push the particle depending on the velocity, the speed it has. So that's what I felt. Somehow it is trying to push each other. So that's what I got with the simulation today. And then I was wondering the concept of having the alpha, beta, theta, delta state, that is possible if we think about, like, if you think about the in an atom, the states of an electron, right? We have that what you call the NP states, right? NP, they are the 268 kind of states. And then they say electron always revolves around the atom at a particular state, and then you'll jump to the next state if there is a gain in energy, or there is it loses energy. So that's when it moves from one state to other. So if we take that concept, then we can see some order, in the sense like, okay, if the particles are in a particular velocity, then it can be in a one state. Maybe it will start with the alpha state. Then as long and slowly it starts spinning, and then slowly then it in only if with that velocity or the spin reduces to a certain level, then only it will move to the next state, kind of a beta state. So if we do, so there is order there, right? In that case, what we are saying, we are trying to say there is an order in that thing. And then if you have that order, then maybe, we can have that layering kind of stuff within the energy particle. So that's another thing I was thinking about when I was trying to some other things, and I was trying to work on this just yesterday and today. And that's when I realized, okay, to get that kind of layering, maybe we need to introduce the something concept, what we have in the atoms, like the state. So there is like a distinct state, for, okay, up to this velocity, it'll be always in the alpha state. And then when the velocity drops down, then it goes to the next state of called beta. So maybe that's what it is. But without that state, the simulation, when you do the simulation, there's an interaction between this particle and tries to push, there's no control over there, and then it can gain speed and eventually goes into the black hole. That's what I realized. So maybe, we have to try that other concept of state also to see how that works. Introduce the state concept.
Naresh,
Yeah.
shall we give a pause and
Yeah.
get the audience whether they are following, they have any doubts or anything? We'll clear it
Sure.
and then. Okay. So now request the audience to tell how much they have understood. Do they have any doubts, questions in this?
Valgavalamudan. I am Leela
Yes.
Gunodan. I am Valgavalamudan. Presentation is very nice. Very nice. He has taken lot of effort and very nicely prepared based on stimulation and all those things. I also little bit know stimulation packages. So only one doubt, it is not related with the Naresh. How the dust particle converted to energy particle, that phenomena only I want to know. Otherwise, how the conversion, what is the force acting on the dust particle to convert to energy particle?
Yeah, see, one more thing in the simulation, right? Another thing is there's a constant compressive force is being applied here. That's why if you look at if you look at it, the energy, the dust particles are everywhere, but the space is also everywhere. The space tries to push the dust particles, right, towards, always tries to apply force on that. And that's what you see here. It keeps moving towards the center. Slowly, all of them will move towards the center. But the center is, the one other thing is, there should be a center. Okay, it needs to form a center. Without center, there's not going to be energy particle. A center needs to be formed. Only when a center is formed, then the this whole energy particle will come into picture. Then everything will start rotating about that center, and the space keeps pushing back.
You mean to say galaxies center? There are many galaxies, some 40,000 crore galaxies in the universe. Yeah. So yes, that every galaxy has got a center point and a black hole, and a center point and black hole. That causes the particle to move around and makes it, when it makes a movement, it creates energy. That is a Sivagalam, Sakti Galam. It makes to Sakti, it makes to gets energy from the stable condition to energy condition. We can say that spiraling of galaxy's particle makes the energy particle energize.
No, that is at the macro level, right? If you go from macro level to the atomic
Okay.
level or even the smaller, the same kind of stuff exists, right? That's what we are saying.
Okay.
Whatever you see on the galaxy level, the same kind of stuff exists in the energy particle level also, right? That's
Exactly.
what yeah, okay.
But still where from that energy comes for spinning, that
The
is
space,
unknown.
right? The space. Basically, everything comes from the space, right? Space is the one that driving everything. That is the one keep compressing stuff, and it has infinite kind of energy, right? The space. So everything comes from the space is the one keep pushing stuff, right? So the whole thing is from the space.
The explanation is very nice, easily understandable, and easily we are getting very good information from this presentation.
Leela Vinodan, you raised a doubt, you got an answer. Dust particle and energy particle. What is the relationship between the two?
Dust particle is stable and no movement. Am I correct, sir?
Naresh?
Yeah, dust particle. See that if you look at my PowerPoint, right, dust particle also starts spinning, right? Only when there is a spin, when the space, right, because the compressive force at that single point where it starts folding, and that becomes a dust particle, and the dust particle starts spinning. That's the whole thing. That's when it becomes a particle, dust particle. If it doesn't spin, then it's a space again. Only when it starts spinning, that becomes a dust particle. So that is the activity there in the dust particle, and these dust particles space keeps pushing these dust particles together closer and closer, and at some other part at some places, right, the dust particle starts becomes space again. It becomes space again. So when the dust particle becomes a space, at that point it's the center kind of a stuff, and then the other particles will starts rotating around that. That's what I felt. Like that's where the center is forming, and then the whole thing starts spinning around that center, slowly. And that's what you see in the entire thing, the groups and groups of, if you look at it, there's only dust particles, and then the groups of them starts spinning, and they make the atomic particles, electron, proton, neutron, everything, and those things together make an atom. So basically it's a kottu iyakam. That's what, if you say, Maharishi keeps saying it's a kottu iyakam. So there is a dust particles. It's like ocean filled through everywhere in the universe, and everywhere there's a groups of action, right? That's the energy particle, and that those two together join and make the atom, like that. So
Naresh,
that's what yeah.
See, in a spinning system, the dust particles spin, the field also spins. Isn't it? Whenever there is a spinning system, you must have a central axis around which they spin. And you have a velocity gradient from the periphery to the center. The periphery has maximum velocity. As you move towards the center, the velocity comes down almost to 0. And when it is 0, it is in the center and it is taken up by the space at the center. That is the black hole mean, isn't it?
Yes. Yeah, that's right.
So this velocity gradient from the periphery towards the center is fundamental. And maximum speed is at the periphery, gradually comes down to the center part where it is 0. I just heard you stressing that the particles, as they come to the center, they become, they gain the speed, they move fast, you said.
Yes, that's what I noticed in the simulation. That's when I started looking at other things. Is that real think that's when
But it
this
is
hurricane
again,
stuff.
it is again the basic fundamentals of the spinning system.
Mm-hmm.
The speed will be more, but the velocity will be less. The movement will be less, right, Tanaya?
No, no, no. When the speed is more, the velocity is also, spinning speed is more. The velocity is also more. When the spinning speed comes down, the speed also comes down. Velocity comes down. There are two speeds, spinning velocity and the linear movement.
Linear, yeah.
That velocity is also there. So both comes down as they are pushed towards the center, attracted towards the center. The interparticular distance is high at the periphery and they are free to spin. The interparticular distance towards the center is much less, and the proximity of the particles itself offers some resistance to speed. The specific gravity, the collection of particles are more towards the center. On the periphery, you have a free space zone where all the particles are pushed towards the center, isn't it? Which you pointed out, Naresh.
Yeah. Yes.
Yes, this is because as they lose their speed, gets their speed reduced, they come towards the center. If the speed increases, they will move to the periphery, and if it exceeds, they will leave this system and go into the universal system.
Yeah. That's what. But the only
So
thing
that
is, see, there is what I'm
basic
seeing.
fundamental. That is the basic fundamental which we cannot forget. We cannot forego this to go about. If it is now, if the particles nearer to the center have higher velocity, it is something is wrong is there.
Yeah, that one thing I need to again study that, why there is some particles, but that's when I noticed, right? See, that's when I started looking at these things, right? In the hurricane also it has similar behavior, right? So if you look at it at the center, here it says the light means the dark one in the center.
Yeah, if may interject, there is a slight misconception that I want to clarify. If may interject, what
Good.
Naresh is seeing is correct, because we are confusing with the term speed and velocity. Okay, speed is an object moving at the distance that an object moves is speed. Velocity includes direction. So when you go to the center, the direction rapidly changes. The speed is slow, but the direction changes rapidly. So in our visual peripherum, it looks as if it's fast, but the difference is speed. When it goes around, when it tries to go to the center, the distance that it travels is much more than the distance when it travels when spinning around in the center. It looks faster because the direction changes faster. So speed versus velocity is always a debate. Speed, if you're looking only at speed, it is slow. It is very slow at the center. But when you look at the velocity, which includes direction, the direction changes rapidly. So it looks, from a velocity point of view, it looks faster, but the speed is much, much relatively slower. So that's one point I wanted to clarify, because we always get confused between speed.
Tarun. Is it Tarun?
Yes, Aya.
Right. See, the direction changes, and if the spinning velocity is not coming down, what will happen?
No,
It will move. It will move away from the center.
Spinning
It will go.
velocity is different. What you say is correct, Aya. Spinning velocity is different. I'm just only talking about the term and how it is visualized. Why the velocity looks faster at the center is primarily because the direction is changing rapidly, not the speed. Speed is slower. So what you say is right, but when you visualize it, it looks faster because of the change in direction, which is very rapid.
Even the direction and the speed which you mean is faster in the periphery and much diminished towards the center.
Correct, yeah. Because it appears, what I meant is it's not faster. It appears to be faster because the direction changes at a very short distance, right? So when you have a longer distance, it appears that it is not changing faster. But in reality, when it's at the periphery, it moves faster and changes faster. But because of the area surface is very small in the center, it appears, I'm not saying it is faster, it appears because of the smaller space, it appears that the direction is faster, moving faster, hence the velocity looks faster. But in reality, what happens in the periphery, the direction and the speed is faster than in the center. So people have to understand, when you look at the simulation, you only look at the
Can I add a little bit?
Yeah, sure, go ahead.
Yes, please.
Actually, in the outer particle, the angularity
Velocity.
will be less, and the inner particle omega, that is called the angular momentum, velocity. Angular momentum, inner particle, more angle it has to bend and rotate. At outer portion, it has to make a less angularity and move it. It is a vector quantity.
Correct.
That is, angularity is nothing but direction changes. It is called a vector quantity. And if there is no direction changes, that is a scalar quantity. All about what we are talking is a vector quantity. It has got a angular movement that is called omega in the formula. That is figuring in our this thing.
Correct. Yeah, that's exactly what I wanted to say in layman terms, but what you said is scientific terms. Correct. Yes.
So the outer particle will have less angular omega, and inner it has to rotate more angularity. Angle of movement will be more. That is the only difference. And the distance between center to the particle away from center, that will r square will vary.
Correct. Yes.
Am I?
Yes. That's what I was trying to say in layman terms, not in terms of angular omega.
You don't know, then give
Yes,
a
sir.
self-introduction for yourself.
Sir, introduction. I am Leela Vinodan, worked in BHL engineering department. I have visited for some 4 or 5 countries, America, some 2, 4, 5 times, Germany, France, Australia, New Zealand, like that due to official requirement. And I have retired in 2018 as a GM. And after that, before for the past 20 years, I am involving in the Vedatri Maharishi activity. But I did MSc Yoga also, but not much of contribution. But after retirement, I could make some research paper publication I was trying. Sir, do you remember once we have met at Aliar in the morning at a wellness program? I was suggesting some 2-3 sessions, and I have sent a message also. I have talked to you 2-3 times regarding some new concept of why someone is going up. ஒருவர் வாழ்நாளில் உயர்ந்திருப்பதும் தாழ்ந்திருப்பதும் எதனால்? So on that research I am trying to make. Like that, I am doing some research work, and Zoom talking also. Earlier Zoom IT department, sometimes the universe formation, some 2-3 Zoom formation I have made. So like that, I am trying to understand the more physical. I am a little bit having some basic knowledge on physics and mechanical and thermal energy. As a mechanical engineer, I could understand these things. So I am trying to understand the Mr. Naresh presentation. It is very nice. He has taken a lot of effort, and he has given a very nice presentation, easily understandable to everyone. Thank you, sir. Whenever I had a doubt, I try to intervene.
Please,
Thank
please.
you, sir.
If you don't raise the doubt, then
Yes.
you are selfish.
No, sir.
Right.
See.
Okay.
Okay, sir. Okay.
Naresh,
I have
go
another
back.
doubt also, yeah, before we go to Naresh. So if
Yes.
yeah, so the formula that you formulated, right?
Hmm.
Newton's formula relies on constant G. When you make it transactional, it completely throws away the equilibrium across, right? So you have a
Mhm.
transactional speed, and transactional speed is not constant. Versus
So this is the spinning speed. What I said was the spinning.
that's
Sorry.
not constant depending on where
Yeah.
the particle is.
Yes. That's right. This is not constant. Yeah, that's true.
Right.
Because
So
that I was trying to see if that layering effect will come, but that's what, unless we enforce it, kind of a stuff, looks like it's not going to happen. Because if you look at this, right, there's interaction between the particles, right? That's where it kicks in, right?
Right.
So we're not seeing that. I was
Yeah.
trying to see what we can do.
Newton, that's what Newton did, was that instead of just, though the G is constant, which is again determined by empirical experimental thing, use something like the mass of two objects, depending on the.
Yeah.
So in this case, my interesting question is, I'm not questioning why you did it. There is
Yeah, go ahead.
two mass, right? So
Mhm.
how did you devise when there is only one mass particle? There's no two mass particles. There's only one particle that you're talking about. How
Mhm.
you come up with the idea that instead of using gravitational mass ratio, you took the transactional speed? How did you come with that idea? So I'm not questioning why you did it.
Yeah.
How did you
No.
derive that?
I was thinking, like, right, whenever the particles see, there is interaction between, and that's why I said, if you look at the power point, I also said there's influence radius, right? So within
Right.
that influence, right, there's influence radius is there. So
Mhm.
only those particles will affect the particle in consideration. So that's what thing I was thinking was, the particles are everywhere. I don't want to go and then say, okay, what is the particle at that very far, right? Only the closer particles is going to contribute to this force on this single DDP. So I introduced this concept of influence radius, and within that, whatever is within the influence radius, there's a spin. What I said was, there's a spinning factor. Okay, basically when its periphery is going to have high spin, and then when it moves closer and closer, there's a spin is going to reduce slowly.
Right.
So based on that, so what is the spin influences the repulsive force. That was my assumption. Okay, the spin is the one that's going to say how much it's going to repel each other, right? So that's what I thought.
Got it.
So
And
I
then
introduced the concept, factor,
your
and then
transaction
based on that,
speed is again based
yeah.
on empirical value, right? You experiment and
Yes.
try to find out your transaction.
Yeah, that's very hard. It's like I try to reduce that. When as time progresses, right? I try to reduce the spin so that when it moves towards the center, the spin will reduce. That was the thought I had, and then I keep reducing as the time progresses. I reduce the spin, hoping that they come closer. Closer and closer to each other. So
Do you
that is the.
Brilliant.
do
I mean,
you
I'm just
control?
trying to understand your mind. That's it. So I'm not questioning you. It was a brilliant.
No. It's good. I like questions. That's when I start. I can think more.
Conceptually
Because
well built. What I'm trying to say is it's conceptually well built. I wanted to understand your brain behind it. That's what I asked. So thank you.
Naresh, you can reduce the spin or increase the spin of the particles in the observable field.
Yeah, I can see. We can, right? See, right now it's like I'm in the code I'm doing, but we can add more like a UI thing, and then we can start playing around. Increasing the spin, decreasing the spin, or what is the gradient kind of stuff we need to apply, right? Right
If
now,
you
I
can,
keep. Yeah.
if you can increase the spin or reduce the spin, then it alters the movement of the distribution of the energy particles, which
Yeah.
are represented in the projection.
Yeah.
So
So we need to, yeah, I need, yeah.
such a thing doesn't happen in nature. Selective reduction of the spin or increase of the spin doesn't happen. The spin is the product of the repulsive force. A compressive force of space and spinning speed is the resultant, the spin velocity. Spin is due to the compressive force and repulsive force interaction.
So that's one of the question I had in the beginning, right? So this is when I was thinking, right, when you say in the beginning, when you say compressive, only the compressive force is not going to make the particle spin, right? There should be some kind of a tangential force acting on the particle, right? And that's what will make the particle to spin, right? That's one thing.
Green is the tangential force.
Yes,
there.
yes, yeah.
And
exactly, tangential.
When the compressive force becomes the repulsive force, after meet each other in the opposite direction, at the center, they change their direction, they become the repulsive force.
That becomes that. Can we say that's a tangential force? Can we say that?
Yeah.
Okay.
That is what you have showed on.
Yeah.
I can add one comment.
Yes,
when the
please.
compressive force slippage creates the tangential force. Slippage between two particle when it slips one over the other, that creates the tangential force. Then it becomes keeps rotating. May I correct?
Yeah.
When this compressive force, yes, let me interfere. When the compressive force acts on 360 degrees, when the compressive force acts globally, up and down, right and left, in all the 360 degrees, they act globally. When they act globally, there is no way of the energy particle managing this compressive force in 360 degrees. And only way that is allowed is to spin. And that spin, if the spinning velocity matches that of the compressive pressure force, the particle survives. If it is less than the compressive force wins over and annihilates the energy particle. It becomes slow and slow. It becomes it becomes space again. So this interplay of the compressive and the repulsive force and the spin of this thing, energy particle. The energy particle spins. It has no other place to go anywhere. To manage the compressive pressure force, it spins. This I have noticed in massive crowd when there is compression at points. The people there, they just spin to wriggle out, to pass out of the crowd.
Can I interfere, sir?
Want to interference. I want to have that.
The difference between the compressive force and the spinning force creates the energy particle.
Yes.
The difference between
the dust particle.
The dust particle spinning force and the compressive force, the difference of these two forces creates the energy particle and it moves downward. Am I correct, sir? My understanding?
Agreed.
Yes.
And now you get the answer. Difference between the dust particle and the energy particle.
Yes, now I got the answer after
Yes.
this. Now I got
Content-wise,
my answer to
yeah,
my question. Yes,
right,
yes,
right. Content-wise, both are same. Dust particle and energy particle, both are same. There is no change in the content of the particle. Matter is the same. But the dust particle, the spin is less. In the energy particle, it is more.
No.
And the energy particle survives longer period because of the spin. Dust particle may wither away. Dust particle has come out of the result of increasing self-compressive force. The spinning of the energy particle manifests. The dust particle acquires spin to become energy particle because of the difference between the compressive and repulsive force. Am I right, Rila Vinodhan?
Yes, sir. Yes, yes. Correct, sir.
I'm not a
Correct.
physicist.
Very
Right.
nice. We are learning from you.
No, this is what I have seen in Maharishi, even though he has not studied so many subjects of science, branches of science, he was able to answer to all the questions.
Intuition knowledge.
Intuition or the amount of static absolute space within you. When it increases, you manifest that. Okay. I think we are boring the rest of the
No.
audience.
No. Yes, let them also contribute and try to ask their doubts.
No, they may like ourselves proceeding to the presentation sooner. What do you say, gentlemen?
Yeah, as it is spinning, it may not be the circular motion, it could be the spiral motion.
Spin is rotation, self-rotation. And the self-rotating particle, energy particle, moves. That depends on the field in which it moves.
Sir,
And
what she is asking, the crackers rotates in the spiral way, and that is the whether that is a spiral is like that, or if you put a drop of stone in the pond, it spreads out all around equally. Which method, which phenomena applies to this condition? So that is her doubt. I hope so.
I thought she is asking about the jump, the vertical elevation. Which one you are asking, Vijayalakshmi?
Yes,
When the spin,
as it is spinning in the circular motion or spiral motion, it should be the spiral motion. As you are saying, the velocity will be more.
The spiral means just like a screw, a nail. When you rotate, it spins as well as advances deeper. So you have seen the crackers, the chakras, which they go. When the speed increases, they used to jump. When the spinning speed increases, they don't remain flat on the surface. They jump above.
Yeah.
That is
your concept is correct.
The spin. That is the vertex formation within the spin. If you follow the picture of the vertex formation, deep down
yes,
in
and
the
that
spin, deep down in the
is
spinning system, there is a stationary point. As it touches the surface of the fluid level, it expands, it becomes bigger, and there is a space from the tip of the vertex to the top, which
So then we can
explains.
say it is
cyclone storm.
spinning in the
Cyclone storm.
in the spiral wave.
Yes,
Can
yes.
we say that? Okay. So as our Kundalini energy we are bringing from Muladharam to Duriyam. So it's coming the energy in the spiral wave. That is what it is getting into higher area. So the
This
velocity
is
will be more on that concept.
what and
As you're
what
saying.
Vijay expresses, shows is she is always focused at the pivotal point, the Kundalini. And when it is expressed at the compressed central stage, the axis, it jumps. The spiraling takes place. Rotation, spiraling, and jump. Okay. Naresh?
And also it applies with the time, because of the time also makes the spiral instead of spinning within itself.
Naresh?
Thank you. All for
Yeah, yeah. Pardon.
You are very much in the discussion.
Yeah.
Right to proceed, I think. You can proceed.
So the next step. So the next step, I would like to basically to try to introduce these states called alpha, beta, theta, delta states, and then so that it's like a kind of a gradient, So just to force. So if the velocity is the what do you call the spinning speed is a certain amount, then basically it'll be always in the alpha state. Only if it drops, it'll move to the next level kind of stuff, so that we could see this gradient, thing. That's the next step I need to try out. Without enforcing that, so what I see is there's a kind of in the simulation. If you look at the simulation, there's interaction between the particles, right? That is more, and then each one tries to keep pushing each other, and then it spreads everywhere. That's what I'm noticing. The interaction of the between the particles. So basically, if you introduce that state, then what will happen is within that state, the velocity will be the same, right? And basically, what you call not the velocity, the spin will be the same. So it will be the constant kind of thing that we will see, right? That's what I'm thinking. So
neither the spin nor the velocity can be the same. Both changes as they move from the periphery to the center.
Yeah. Yes. That's what.
There
So
is a progressive.
that's what. But the gradient, but within that layer, right? That if you look at that one, within that, if you look at it, within that red field, there it will be kind of a same. Almost, it will be almost the same, right? Within that field, that layer, it will be the same.
Yes.
But when it keeps moving down to yellow, then the speed. This is where when it's moving from the periphery to the, it's going to change. But within that red thing, it will be the particles will have the same kind of a spin speed, everything. That's what I meant. So that's so basically that's what I'm trying to, after doing this stuff. So if you want to, if we say it's going, there's some.
Naresh,
Sorry,
in choosing the color, you always take the with GR. It is present in the nature. So violet is the slowest, and the red and orange.
Yeah. Okay. Okay. Got it.
And if it is represented, it is universal representation.
Okay.
Explain what red is, what green is.
Okay, got it. Okay, good. Yeah, I'll try to. Yeah, that's a good thing. Okay, so that's what.
Yes.
So next thing is I'm going to work on this now to get the states into that energy particle, so that's to see within the if the spin is all the same, whether it basically that's going to organize into that layering kind of a stuff. I need to try that out.
Can you give a velocity gradient from the periphery to the center?
Yes. That's what next step I would like to try it out. So within that velocity, it will try to. Today there's no. I didn't say give any velocity gradient. So that's why you see when each particle comes to closer to each other, it tries to repel and then it just flies off. There's no control over there.
So that needs to be added. And
Yes.
if you add a gradient in your projection itself, on the periphery, the interparticular distance is more.
Mm-hmm.
When you come to the center axis point, they are closer.
Yeah.
The number of dust particles are increased in your sample, then they will have no space to spin. That's why the alpha, the beta, alpha, theta, delta fractions come. In the beta region, towards the periphery, not in this projection, sometime later. The periphery becomes less dense compared to the center. And the interparticular distance comes very much less, and they're almost, it is, a particle is touching the other particle also. When so much of interference is there for movement, the velocity will come down, has to come down. And only when it becomes zero, it can get into the black hole. Only then it can become space. Then only it can become.
I need to. Yeah, that's what I need to take velocity into consideration. Right now, there is no grade. I was working on the spin, right? So that was not focusing on the velocity. So instead of that, I need to look at the velocity and then take care of that, apply the gradient and try it out again.
You have to add velocity to it.
Yeah.
And I don't know whether I am boring because I'm repeating it. That is, as they come down, become slower, and the field, the delta field, the central region becomes more dense. The densest portion is at the core, just like Earth. Go deep and deep, it becomes very this thing. And here I want you to follow me when I say on the surface of the earth, you have atmosphere just above water is hot air and air. And if you go deeper to water, it becomes solid rocks. And below the solid layer, what do you have across the earth? Leela Vinodan.
Yes, sir. Surface, earth surface, hard core and inner core, and inside center is molten stage, earth molten stage. But at the surface, due to cooling effect, it is a hard crust formation is there.
Yes, it is because of the spin, because of the compression of the particles, matter, it becomes solid.
Solid is correct, sir.
Yes. what is there below this solid level?
Semi-solid. Semi-solid.
Now, right from this point of the solid rocks there, below that you have the yielding of the
Yes.
density of the rocks.
Exactly.
It becomes semi-solid, it becomes liquid, and it
Liquid.
becomes fire. It becomes
Vapor.
fire, and
Vapor.
still interior to the fire you have liquid air,
Yes.
and below that air you have absolute space that is on
Yes.
the axis of the earth. There is a reversal of the Panchabhutas. The behavior of the Panchabhutas at the periphery is rocks, earth, solid, and above that is liquid, water in the sea, rivers, everything, springs, everything. And above that you have the hot air. That is the this thing. As you go up, the air becomes cooler, and
Yes.
still, if you go up, we have gone through the space. We have seen people going through the space. So it becomes, the air becomes thin, and yields
Less
to
dense.
space. And the reverse direction takes place at the solid level in the base of the bed of the sea. Below that, the rock level yields to the hydrocarbons and the streams, water there. When we do a bore well, you tap that water out. And below that, you get the hot air, which becomes fire, which you explain because of fission and fusion, you get the fire. The chemical reaction may be different, but the Panchabhutas order are reversed below the solid rocky level, rocky state. And the reverse change continues to go to the center where it becomes absolute space. Okay?
Absolutely correct, sir.
And Naresh,
Nice.
does this change
Yeah.
creates any change in the behavior of the particles in your simulation? This orbital order, beta, alpha, theta, theta, has to come up according to nature as it is seen in the geography. Planets, in the stars, everywhere.
Okay.
That has to be preserved in the simulation.
Yeah, I think that's what I need to. Yeah, I need to try that out. Putting that velocity when I apply the velocity gradient, and based on the velocity, it takes a particular state. That's what we need to do. Just like in electrons, in the atom, what we are that NPS, right? Those states. So 268 that state. Similarly, I think here we need to put that based on a velocity gradient. We need to put that state. I that's what I was thinking, and after looking at it, maybe that's what I should try it out and see.
When the spinning speed of the dust part of the energy particle comes down, the density of the energy particle also will come down. It will try to expand. It will become a cloud then. Then it will become magnetism. So that aspect also has to be retained while designing this simulation.
What is that, Aya? Can you repeat that, please, one more time? I didn't get the whole thing. Yeah.
As it reaches towards the center, the spinning speed as well as the direction, the linear speed comes down.
Okay.
When the spinning speed comes beyond a critical level, the compressed nature of the energy particle will yield to become broader, bigger, thinner, lighter, finally to end as a cloud. Instead of a particle, it becomes a cloud. Energy dissipates and the particle dissolves in space from which it has come. It goes back to space where this additional energy given to the space makes it magnetism.
Magnetism, basically, yeah. Basically, that there is a wave that the space contracts and expands, and the whole particle starts around that starts moving, as a wave. That's what. Okay, the dust particles.
So it becomes magnetism. In your simulation, the central point should be space, and a gradual change from space to particle to life force particle, and the Panchabhutas. That gradient should be there.
Yeah.
Am I simplify this? In the diagram, at the center, less dense number of particles should be less, and the outer, the particles are thrown out. So more particles.
No.
This is the initial picture. As it spins, you get the particles pushed towards center. In a short while, you can see a clear rim of a space below the interior to the red line. And then allow it to spin, Naresh.
What is it? What is it here? Sorry.
Allow the particles to spin. It is frozen now.
Okay.
Right, let me see. It is slowly coming to the alpha region, from beta region to alpha region.
Yeah, when it gains energy, right? Sometimes that state will, or it gains the velocity because of interaction of particles. It can move up or down, right? So it depends.
Yes. So, is Mohan ready to tell something? What you have gathered so far?
I am trying to understand. I think I'm a little bit.
Okay. I will trouble you. Thank you. And
but I have one. I have one question, but I don't know whether it is related to it or not. When you say this, we have a surrounding pressure force around every object and particle, and even for gravity of Earth, we used to say. Because of the surrounding pressure force, the object comes down to earth. But my question is, the surrounding pressure force is everywhere, right? In around 360 degrees around a particular object. Why it has to push it in one direction? Like even in an energy particle, why the surrounding pressure force pushes the given particle to the center?
Dear Mohan, it is not in one direction. If you look into the presentation there, it is 360 degrees. It is circular. From the periphery, the direction changes, keeps changes. So, and there is no, if you want to simulate to Earth, the central point is the core of the Earth. So there is gravity, pull goes there. Here, in the space, it is the self-compressive pressure force of the space which is everlasting, ever increasing, which is pushing the particles towards the center.
That's my question. This self-compressive pressure force, it is everywhere around the divine dust particle, but why it has to push it around the center? It can push it everywhere, right?
You're focusing your attention to the particle, but it is existing even away from the particle. It is present all over. And when it acts on a particular particle, it gets concentrated.
Okay, but it is present outside the energy particle also. But why it is pushing it towards the center?
Because
center of the energy particle.
The velocity is low and the spin is also low. So from high pressure to low pressure zone, they move about. Which you see in the monsoon.
Yeah.
Right.
Okay, yeah.
Rajmohan.
வாழ்க வளமுடன்.
வாழ்க வளமுடன்.
The presentation was very nice, actually. A lot of effort has been taken into this. The spinning system is explained very nicely. Spinning system, and at the center, more number of living dust particles are there, and the periphery, less number of particles. Density will be less. That is there. And a spinning system with a tangential velocity, that is nicely explained. He made a presentation also. So when the compressive force is on 360 degrees, so everything is focused up to the center. So how it is spins? So for that only, Malaysia has told and kinematic curing, the time concept is included and as a fourth component. So there's a small difference in the compressive force on the tangential side. That is why it starts spinning. If all 360 degrees compression means everything will come to the center. The whole body will be reduced to a point, single point. So there is a slight difference in the tangential force. So it starts spinning. So spinning also there. Then there is also a linear moment of the center moving away also. No. It is not stationary at the one point. So the whole space is spinning as well as there is a linear motion moving out. It is that combined together. Okay. So association of divine dust particles makes the whole energy particle or life force particles. So there only the delta, theta, alpha, and gamma layers are there. 4 layers, and the center is space, and black color is on it. So their presentation was very nice. Very simulation was very good, and easily we can understand this. It's a very nice presentation. Oh, thank you very much.
Rajmohan, your contribution is change of field, that is from energy particle level, we move to the life force particle level, association of energy particles to the state of life force particle. And when it becomes life force particle, the layering will be more obvious, I think. So that is for Naresh.
Okay, right. Layer, it becomes a life.
Naresh, please note that point.
So what you're saying is, so when the energy particle, when it becomes a life force, there is more order to that. Is that what you're saying?
See, life force particle is association of group activity of millions of life force energy particles.
Dust particles.
Dust particles or energy particles?
Both are same.
But there's a difference actually. Here is only confusion comes.
When the
Hello?
spin becomes more, let me make it clear. When the spin is less, it is a dust particle. When it is more and compressed, takes form, it is energy particle.
Exactly.
Right.
Once ago, yeah. See, so far we were saying that the energy particle is made up of billions of dust particles, right? That's what we are saying, right?
No. Millions of energy particles grouped together. The slower one towards the center, the faster one encircling it, spinning around the slower one, makes it a couple. Like that, it builds up. When it reaches a particular amount of this thing and it starts moving, like not like individual stars, like a galaxy, it moves. That galaxy like state is life force particle.
No, that's life force particle, yeah. But the life force, the energy particle itself is made up of dust particles, right? Is it not correct?
No. We have to go into it. It is a very important point. What are the differences? To me, it looks like both are same with the velocity, density, compression difference between the two. That is the characters that are characterization differs. That is what I think. But I didn't get it from anywhere. I'm just out of my own introspection. I'm revealing it. I may be right or wrong. I don't know.
Okay, because that means the concept, like how we explain everything, should be kind of different. Today, what we say is the dust particles are like a joint, like they group together to make energy particles. And when the energy particles start spinning, and then energy particles start spinning, and there when the dust particles, when it released from the energy particle, that's what comes back and then joins the space, creating the magnetism. That's what we keep saying, right? So but now what you are saying is the dust particle itself, depending on the spin, it's a dust particle or it can be an energy particle, right? That's what you are leading to, right?
Yes.
Okay.
But
1 minute, sir. There only confusion. Naresh, what you said is correct. See, from this phase, dust particles are formed, and the association of dust particle is called energy particle. Then one energy particle, there may be thousands of dust particles are there. And when we say energy particles, this is the energy particles in the universe. When we say life force particle, it is inside living beings.
Living being, yes.
Particle which is inside the human being.
Rajmohan.
Call it as weir. Weir is called life force particles. Only the name of other structure same.
Rajmohan.
This is a confusion takes place in the terminology.
Rajmohan. Shall I add this? That is the energy particles grouped together. Coupling takes place. Associated movements of the energy particles take place and yields life force particle.
No, no. That is thousands of energy particles, rather you say it is life force particle, or the energy particle itself is a life force particle.
No.
Ah.
Energy particle is a simple, single.
No. What is the divine dust particle? Right?
That's
The
why
energy particle single.
Let us go into that point later.
Okay.
When you dissolve this energy particle, what happens? It becomes compression goes off, it becomes loose, it expands, and it expands to form the cloud-like energy field. And that is when merges with the space, it is called magnetism.
Correct. That is correct. See, one energy particle has 1,000 divine dust particles. So suppose 100 particles are coming out.
Listen, Raj.
And it merges with the space. There is a field.
Rajmohan,
Magnetic field.
Rajmohan, you listen. When it dissolves, the compression goes off, spin goes off, it becomes loose and spreads. The energy particle itself spreads. It becomes thin, like a cloud. From the particle state to the non-particle state, it becomes a cloud and dissolves in the space, merges with the space, which is called magnetism. In this, the energy particle is not forming divine dust particle, or is there any divine dust particle stage in the dissolution of the energy particle? Rajmohan.
That cloud is, I could understand this. Only point is, energy particles and light force particles are same. This is your view.
No. Divine dust particle and energy particle are the same.
Same. So, divine dust particle, there is only one particle, let us say. You mean to say energy particles is also there is only one.
Can we say life force particle is a Nidelwinkel?
This is only a
word,
so word only. It's a word only. How do you imagine or visualize?
Yeah, that is what what MBRI is telling, the light force particles, which are shadow wave particles, which will make as a cloud with a magnetism.
Vijay
Cloud consists of, my question is, the cloud consists of what?
Rajmohan, the shadow particle or Nidal particle is given up by Swamiji himself. So don't bring it there again.
That is same. That is only the divine dust particles which are coming out and escaping from the energy particles. We call it as in Tamil wind. And the divine dust particle as Ireitugal. So the Ireitugal finally, when it comes out of the energy particle, it is merges through the space. It dissolves. The whole energy is coming as a magnetic waves with a ripples around the energy particles. So this was I could understand from Maharishi. That is what in our Science of Divinity book we explained in the same way. So from this space, due to compressive force and kinematic wearing, dust particles are formed. Then the association of dust particles is called energy particles. And from the energy particle, some of these are coming out as magnetic waves. And that magnetic waves are called the universal magnetism in the universe. And the same energy particles inside the body, inside the living being organism, it is called life force particles. And when you say life force, it is the circulation of many number of life force particles are circulating throughout the body. It is called a life force.
One
So
more,
that
one more,
we have defined.
one more. The
Ah,
energy
circulation.
particle, when it is comes to body of any living thing, that Panchabuddha's combination gives the life force. Panchabuddha's energies,
No, no.
energy part.
The Buddhas is different. It is the association of energy particles.
Rajmohan,
Let me.
all of you just. So we will have a group discussion between Naresh, Vinodhan, Rajmohan, and Tarun, Vijay Lakshmi. Put together, we will have a discussion to decide what is what.
Okay. Thank you. Okay.
So let us move to the other thing. So many Meena Puvi.
Arulnidhi.
Also, Ramadan. You have anything to say?
No, yeah, a few more times I have to hear the same.
Right.
So yeah,
Okay.
I asked Vijay Lakshmi Amma to send the recordings because I'm not able to hear
Get it.
all the lecture. So I asked her and I will go through it one more time.
Okay, right. Manisha.
Namaste sir, Valga Valamadam.
Mute your
Yeah, Rajamohan, background noise is coming.
Yeah. That. Mute it. Thank you. And
Hello.
is it Leela Vinodhan
Yes, sir.
or Manisha? Yes.
We
We will listen to Manisha and then come back to you. Right.
Okay. Valga Valamadam, everyone. Sir, nice presentation, Nareshji. I mean, I think every slide requires a lot of contemplation to me. I have one, I don't know if it is question or something, but I'd like to make that, I'd like to express that. In the simulation diagram, when you mention the black hole and the circulation of the particles, I was relating it to the human system, human body system, with the genetic center being the black hole. And the black hole itself is absolute space, and being the absolute space, it can create more particles as well. So like what happens in our body system, we are not only taking particles from outside, but also from the genetic center.
Manisha, a minute. The space in the center of the genetic center is having a different physiology and anatomy, and the space outside this thing they have. The space is within the body. It gets intensified, transformed, changes in its behavior. It goes even to the extent of energy particle. So it becomes different. So you cannot take it as the same. Here in the center of the genetic center, it is dissolving. Everything is dissolving into. It becomes nothing.
Okay.
That is it. Space. That's all. That Orientation is different.
Okay, okay. So here in the in this, it just gets sucked in and final resolution happens. Okay, sir. And
Yeah, that
second
is
point
the
was,
understanding.
yes, no, it's thank you for clarifying this. Second point was there was
Manisha ji, before moving into next point, it is 15 minutes extra already. So we
oh
wanted
yeah,
to continue this
okay.
session
Sure,
next
sure.
week, or
Sure,
We
will
will continue next week, but
sure.
in practice, we find that we don't continue, we discontinue with a meeting. So let her finish in less than
sure.
30 seconds.
No
Okay,
problem.
yes.
Yeah. Just wanted to confirm.
Okay.
Thank you.
So in one of the formulas, we use the mass for particles. So I wanted to also know how would you derive or how would you express the mass of the particles was another question. Uh, and one more was the it
I,
was mentioned.
Mhm.
Yeah.
I didn't use the mass there because I assumed in that one of the slide, I assumed mass to be unity. There's no mass there. So basically what I said was the Newton's gravity, right? That R square, right? That M1, M2 by R square times G. Similarly,
Yeah.
to make the interaction between the particles. So basically what I did was instead of a G, for the interaction, I added that, what do you call the spin force, the spin force of the particle. That's what I did. So basically it is like kind of simplifying that Newton. I took that concept, the Newton's concept of gravity, and for the interaction between the two masses. But here I removed that masses because it's so small, there is no mass there. And then instead of the masses, I just kept that only the spin, over the
Naresh,
distance, right? R square. That's what I did.
Naresh, Naresh,
Yeah,
we will
yeah.
try to answer in the next session. It is already
Sure. Okay.
6 more than that.
Yes.
Sure.
So
Okay.
continue the next class, Manisha.
Yes, sir.
Okay.
Yes. Sure. Thank you.
Right.
Thank you.
Good night, sir. Good night. Okay.
Shall we conclude there?
Please, waiting for it.
வாழ்க வளமுடன். Naresh, please join next week with the queries from the floor.
Yeah, I'll
Thank
join.
you so much.
Yes.
வாழ்க வளமுடன். This will conclude our session today with the world blessings. May the world be blessed with plenty of rain. Let practitioners of all prosper, flourish, and grow, and culture progress through the need to share and grow. Let the rulers be beyond feelings of anger or fear, illiteracy, poverty, and all evils made to disappear. Let the true lamp of knowledge burn steady and bright. Our sense of duty guide us along paths always right. உலகமெல்லாம் பருவமழை ஒத்தபடி பெய்யட்டும், உழவரெல்லாம் தானியத்தை ஒப்புடனே பெருக்கட்டும், பல தொழில்கள் புரிகின்ற பாட்டாளி உயரட்டும், பகுத்துணர்வில் தொகுத்துணர்வு பண்பாட்டை உயர்த்தட்டும், கலகங்கள் போட்டி பகை கடந்தாட்சி நடக்கட்டும், கல்லாமை கடன் வறுமை களங்கங்கள் மறையட்டும், நலவாழ்வை அளிக்கும் மெய் ஞான ஒளி வீசட்டும், நம் கடமை அறவாழ்வின் நாட்டத்தே சிறக்கட்டும், நம் கடமை அறவாழ்வின் நாட்டத்தே சிறக்கட்டும், நம் கடமை அறவாழ்வின் நாட்டத்தே சிறக்கட்டும். வாழ்க வையகம், வாழ்க வையகம், வாழ்க வளமுடன். Thank you. வாழ்க வளமுடன்.